Now this is part 2 of my little presentation on staircases. So the first part outline, I was on site and I took the measurements out on site. So when I came back to the workshop, this is what translated in what I can do with the stairs that I measured on site. So this is the arrangement here, and it has to comply with building regulations. So I've got 8 rises up to here. I've got a 9th and 10th. I've got to have 2 lifts, landing, another lift, a 10th lift, and then 3 more here before I come onto the first floor. So that's the only arrangement I can make work. Now I would like to have had a rise that was much lower than what I have there. So the maximum is 220, so it's quite a steep lift. Why am I caught? I'm caught because there's a doorway down here that I can't come forward with an extra tread. And I'm caught up here as well because there's the actual distance above here won't allow me to put in an extra tread up here. So I have to have 13 lifts and 12 goings, 12 goings, so 12 treads. Now, just to working out of it, for those who are probably connoisseurs or who are interested in setting it out and how do we do it, you'll see there I've stuck it to a string. I've already run off a series of housings on the actual stairs that I'm making. So you'll see there's a rise. I don't know if the camera's picking it up here. It'll certainly pick up this one, I'm sure. There's a going here and there's a rise. And there's also a line here, you'll notice. Now I'll come back to all that on the next video when we're doing the setting out of the stair itself. But to work out how and why you do a stair in a certain way, or how you approach it, is the angle of attack, as I call it, is very important. Now, when I come back to the workshop, or when I'm in the workshop, I use a marking rod. You have to find out where you started a stair. So no matter how complex a stair is, you always bring it back to basics. So what do I mean by that? A stair is basically a triangle. You've got a rise and you've got a going. So you've got a full distance here and you've got a full height. FTF is floor to floor. Now in order to work out this stairs, it was a little bit more complex than a standard. I had a fixed width here and I had to have 2 risers. So the starting point for the stair that I'm working on at the moment had to be here. I had to start here because that is a fixed distance and that there is a fixed size for a landing, and so is that. So, and I had to stay within building control regulations for the width of the stair, the size of the tread that sits here, and the same thing here. That must be symmetrical. Okay, so in my case, I set out risers number 9 and 10 on a board. So all my measurements and my 2 other strings are my 2 other flights. The top flight is that over here, and the bottom flight is over my head here, coming up. So all I did was sort out the section that I have above the top, that distance there. And once I had that sorted, I'm away. Everything else here is the same and the same. So that's my striking out rod. You don't always need a striking out rod. Every stairs will present different problems and different compromises. So we'll leave that to one side for the moment. That's the arrangement of what I'll have. I'll have handrail running up here, newel post, handrail here, and then landing up here and a handrail here as well. So how do I work it out? This is what I do. Now other people that make stairs, other joiners, other people approach things differently than I do, and I've changed the way I've done things over the years as well. So every stairs is a triangle, literally a triangle. Always bring it back to basics. That FTF is your most important measurement. If you get FTF wrong, the whole stair is wrong. What you've got effectively is firewood. So floor to floor, you must measure from the floor, ground floor, to where you land up on the first floor. You need to know, what is the first floor finished in? Is it finished in thickness of carpet, or is there a timber floor going on above? And you'll also need to know what's going to be finished on the ground floor as well. So once you've that worked out, you have your FTF distance. So I've taken just a triangle here just to explain what I do. So I'll have a what's called, the total distance is called going, total going, and that's the total rise. So that's R and that's G. Now pitch line there, any triangle that we take there, a carpenter, roofing carpenter is concerned with that there. He's concerned with that. He's not interested in this. He's interested in the rise just to get the length of a rafter. Stairs is the very same thing, only we just come under it here, we put a rise on it, we put a going, we put a rise going. And once we get the first 2 rises, we get a line underneath here which is called a pitch line, or the pitch line effectively is on top of the nose and stair coming up along the stairs. So I've just put in an example here just to show you what I do. So let's just take an example. Standard ceiling height in Ireland is around 8 foot plus another 250 mil to go up to the first floor. So I put in as a standard height in Ireland of normally about 2690. I'm dealing in millimetres. Anytime I come to joinery or furniture, I deal in millimetres. If I'm doing carpentry or roofing, I prefer to use the old money inches and feet. So in this case, what am I doing? I always like to start up here with a rise. A rise is the amount of lift on any stair. So in this case, a 175 lift, if you can get it on a stair, you're doing very well, because you'll get a low lift and it's easier to climb the stair. And a going of around 240, that's a really, really nice stair if you can get it. The lower the rise and greater the going, the nicer the stair lift. Okay, it's easy to get up there. Now, doesn't always work out that way, because sometimes the spaces are tight and you've got to really get them into tight spaces. And that occurred in my case here. I was down to one permutation that will work. So when I'm designing a stair and I want to do the mathematics of it, I'll have a rise, I'll have a going. So in this case, there's a standard going around 3,300. So I've just put an example on the board here. So let's start here. So the floor to floor is 2690. What I always do is I'd always divide 175 into that figure, always. So if we do it on top here, 2690 divided by 175, that'll give you 15.37 risers. Now you can't have 15 risers and then 0.3 of a riser, that's impossible. So you're looking for the round number, you're looking for that number there, just 15. So we go back then and we divide 15 into 2690, and that will give me a height for the riser of 179.3 up from 175. That's my rise. That's quite a nice rise, 179. That's okay, that's good. So if I have 15 rises, I'll then have 14 goings. So the 14 goings, then I simply divide 3,300, which is this distance here, that's the going, the total going. In other words, what people call the step, what you stand on. So that's 3,300 is the total distance. There may be a doorway here, you have to keep away from that. So you divide it by 14 and that'll give you 235.7. So if we just round up, we'll stay with the 179.3, I'll round that up to 179.5. I try and get the rise as accurate to the measurement as possible. So I have no difficulty putting 0.5 on setting it up to 179.5. I don't have an issue with that. So some people don't bother with it, but then 0.5 multiplied by 15 will give you 7 millimeters of a distance. So I like to be accurate with that one so that the stair is perfectly level. The going can be rounded up at 235.7, just simply rounded up to 236. Now, a lot of people don't bother doing this, but I like to use a little bit of trigonometry. You're just getting the tan of the angle in here. So if you're not familiar with the tan of an angle, you'll see, go to YouTube and it'll show you the working out of it. So it's actually quite simple, but you need a scientific calculator. Now I would use trigonometry quite a lot. So in this case, if I want to get the tan of an angle, I divide the going into the rise. So in this case, the rise is 179.5. So I'll tap in 179.5 and I'll divide it by 236. So 236, and that'll give me a ratio of 0.07659. So on my calculator, I go to shift button, I get the inverse tan on it there, and I press equals, and that'll give me an angle there, a pitch angle of 37.25. Now that's beautiful, that's perfect for what I'm doing here, for the example that I have here. I've picked a perfect example, of course. So that's the tan of the angle. So the angle in there is 37.25. The maximum we can have in a private stair in Ireland is 42 degrees. Now the one I have up here is working out at 41 degrees. So when you have that done, the beauty of having the actual angle there is that you can set that angle on your chop saw. If you have a chop saw, you can cut that angle, and it actually helps you to set out the stair itself. Not alone that, but that angle, when you have it set, that's the angle to cut all your spindles, all your handrails. That's the pitch angle that you're going to be working with. So you don't have to go farting about and trying to get the measurement off a board or trying to set it up on a board. You already have it just by a bit of simple trigonometry. Now, that's the best, that's as simple as I can keep it to put it on camera for anybody. So that's what I do in my situation when I'm doing a stair. No matter how complex the stair, whether it goes twists and turns, or what way, whatever the layout is going to be, you always bring it back to a simple triangle. It doesn't matter how many times it goes up, turns, twists, it doesn't matter. It's irrelevant. You need to know the going for each particular part of that stair, and you need to know the total floor-to-floor measurement. That is the single most important one. So just to recap again, you take that measurement, divide by 175, because that's a nice standard rise. When you come out with something like this, 15.37 risers, you can't have 0.37 of a riser. You have to have a fixed number. Okay, so there can't be decimals after it. So 15 is the number here. You divide the number now 15 into that, and you get 779.3. That's what you want as the setting for the rise. The going, in other words, then there's always going to be one less going plus the landing thread, which happens in up here. So that's irrelevant. You needn't worry about that guy at all. He'll work himself out, because the last rise takes you up to floor level, first floor level. So once you have 14 goings, you simply divide the 14 goings into the total going, which in this case is 3,300. You get 235, rounded up 0.7, rounded up to 236. You're only going to gain a few millimeters in the length of the stair overall, and as long as it's not impacting a door that it has clearance maybe about 400 mil, you're fine. So divide the going into the rise. That's what you do. Divide going into the rise, and you'll get the ratio there, 0.76059, and get the inverse tan. Find the inverse tan function on your calculator, and it'll give you the pitch angle, 37.25. Pick up that angle, go along to your chop saw, cut that angle on a piece of timber. I have one cut somewhere here. I'm just going to go off camera for a moment. Now with the stair I'm doing, that's the pitch angle that I've worked out, is 41.32. So that's the angle for all the spindles that will be cut on the stair thereafter. So that'll be the angle. So it's very handy to have that. You don't have to be working it out again or trying to take it off the actual stair itself. Now, as I said, I've run off one of the strings here, so the next part of the video, the third part of the series, will show you how to apply that to this here, and then how to set up the router and how to actually apply it to the template. So this here, once we've the first two threads done there, or the first two rises, it's actually quite easy after that. So you'll see that there's the minimum of setting out I have for that whole staircase. That's all I need. I have to comply with building regs all the time there. So I have another little pad here, if I can put my hand on it, which, where is it? If I look around, oh, it's here beside me. So just to show you, things to consider when you come to a stair, everybody, is things to consider. The rise, very important. The going, very important. The pitch, very important. The width of the stairs has to be, there's a minimum measurement to comply with building regulations. You have to have clear head height over the stair as you climb, and you must have also, if it's a sloping pitch above you, it also have to have a clear distance. Normally it's 2 meters. So the handrail height, the minimum as you rise up the stairs, is now 900 millimeters. That's the minimum, and the heights, and if you're onto a landing handrail, it's 1100. This is Irish regs now from 2014. Don't forget to look at access doorways upstairs. There's minimum requirements on the ground floor, and there's requirements on the first floor. It's around 400 millimeters away from where a stairs lands. So can't tell you any more than that. I think that's all I have. That's the way I work it out. Other people can set it out with a height rod. There's different ways of doing it, and it doesn't matter once you end up with the same result. My approach to everything is Occam's razor. It's the single most direct way to the solution, simply because it saves time, and when you're working alone, you want to be able to produce the stuff fast but accurate as well. There's no little grey areas where, you know, I might have to work this or I might have to work out that. So have your planning done, have your angle of attack done before you start. Have all that done. You know, that's a scale drawn of 1:10 just to show it, to get it into the kiln before I start anything. And once I have it, I'm away for slates then. In my case here, there's my rise, there's my going, and I have my pitch angle already worked out there on the piece of timber. I've done that in the chop saw. The next thing then is to apply the actual information I have here onto the board and make sure that I run off the strings left and right. So that's part 3. So we'll see in part 3 of the series on stair construction. Okay, over and out, Shinawil.